2004, Nushabad, Iran. A small town in the central desert. Population 6,000. A man is digging a sewage ditch in his basement. His shovel breaks through, not into a pipe, into emptiness, a void. He shines a flashlight down. The light disappears into darkness. He drops a rock. 1 second, 2 seconds, 3 seconds. Finally, it hits bottom. There's something under his house, something big. He calls the local authorities. Archaeologists arrive. They descend with ropes and lights. What they find is impossible. A city, 18 meters underground, 3 levels deep. Tunnels, chambers, living quarters, storage rooms, ventilation shafts, water systems. And it's not just under his house. It's under the entire town, stretching for miles, connecting hundreds of homes. An underground city that's been there for 1,500 years, and nobody knew it was there. This is Nushabad, also called Uyi, the city of wind. One of dozens of underground cities buried beneath Iran, some 3 stories deep, some 10 stories, some stretching for over 30 kilometers, carved entirely by hand, no modern tools, no machines, just picks, chisels, and human determination. Built during the Sasanian Empire, around 500 AD, designed to hide entire populations from invading armies. But Nushabad is just one piece of a larger underground world. Beneath Iran's deserts lies a 3,000-year-old water system called Qanats, underground aqueducts, over 37,000 of them, totaling more than 750,000 kilometers of tunnels, nearly twice the distance from Earth to the Moon. Hand-dug, gravity-powered, still functioning after 3 millennia.
Ancient Persians didn't just build cities on the surface. They built an entire civilization underground. A hidden world of tunnels, cities, and engineering so advanced, we're still studying how they did it. This is the impossible world under the ground of Iran. Nushabad Underground City, central Iran, 18 meters beneath the desert surface. Let's go down. The entrance is narrow, less than a meter wide. You have to crouch, descend a carved stone staircase. The temperature drops immediately. Surface, 40 degrees Celsius. Underground, 22 degrees Celsius. Natural climate control. The stairs spiral downward. First level, second level, third level. The first level opens into chambers, low ceilings, 1.5 meters tall. You can't stand upright. This is intentional. Invaders wearing armor couldn't fight effectively here. Defenders knew every tunnel, every turn, every trap. The chambers connect through narrow passages, some only 60 centimeters wide. You have to turn sideways, squeeze through. This wasn't for comfort, this was for survival. Carved niches in the walls, oil lamp holders, storage alcoves, living spaces where families huddled during invasions. Mongol armies, Arab conquests, Turkic raids. When enemies approached, entire villages vanished underground. Archaeological evidence shows people lived down here for months at a time. Complete darkness, air from ventilation shafts, water from underground springs. Descend further. The second level is larger, higher ceilings, more chambers. This level held supplies, food storage, water reservoirs, carved from solid rock. The walls show tool marks, thousands of chisel strikes, years of labor. Archaeologists estimate it took multiple generations to excavate Nushabad. Families working in shifts, removing rock by hand, 1 bucket at a time. The deepest level, the most sophisticated, water collection systems, ventilation engineering that still works 1,500 years later. The air is breathable, fresh, but you're 18 meters underground with thousands of tons of rock above you. This is the engineering marvel. How do you breathe underground?
Vertical shafts, some stretching all 18 meters to the surface, carved at precise angles. Natural convection. Hot air rises, cool air descends. Constant circulation without pumps or fans. The shafts are disguised at the surface, hidden among houses, in gardens. Invaders walking above had no idea there were thousands of people directly beneath them. Water seeps through rock layers, collects in carved channels, flows to storage chambers. The gradient is calculated perfectly. Too steep, it erodes. Too flat, it stagnates. Ancient Persian engineers understood hydrology at a level that impresses modern civil engineers. Nushabad isn't one structure, it's a network. Tunnels connect hundreds of buildings. You can enter one house and emerge 3 blocks away, entirely underground. Archaeologists have mapped 4 kilometers of tunnels so far. Ground-penetrating radar suggests there are over 20 kilometers total. They've explored maybe 20% of it. And Nushabad isn't alone. Northern Iran, Saman underground city, 3 levels. Southern Iran, Kish underground city, 10,000 square meters. Western Iran, subterranean structures under modern cities discovered during construction projects. How many are still undiscovered?
Now let's talk about the engineering achievement that made Persian civilization possible in the desert, qanats. Iran is a desert. Central Plateau receives less than 250 millimeters of rain per year. Surface water evaporates instantly. Rivers are seasonal. Yet ancient Persia built an empire here. Cities, agriculture, millions of people. How? Qanats, underground aqueducts, the most sophisticated ancient water system ever built. Here's how they work. Step 1. Find water. Persian engineers, called muqanats, identified underground aquifers at the base of mountains. Water grounded here from snowmelt, trapped in permeable rock layers. Step 2. Dig a shaft, vertically down to the water table, sometimes 200 meters deep, entirely by hand with primitive tools. Step 3. Dig a tunnel, horizontally from the shaft toward the village or city, following a precise gradient, just 1 in 1,000, 1 meter of drop per kilometer of length. Too steep, water flows too fast and erodes the tunnel. Too flat, water doesn't flow, becomes stagnant. They calculated this perfectly, without laser levels, without surveying equipment, using astronomy, mathematics, and pure skill. Step 4. Dig more shafts. Every 20 to 50 meters along the tunnel route, dig another vertical shaft to the surface. This serves 3 purposes. Remove excavated rock, hauled up in buckets, provide ventilation for workers, and enable maintenance access. From above, qanats look like a line of craters across the desert, circular wells, dozens or hundreds in a row, stretching for kilometers. Aerial photographs show them everywhere in Iran, lines of holes leading from mountains to cities. Over 37,000 qanats in Iran alone. The longest, over 70 kilometers. The deepest shafts, 300 meters. Total length of all Iranian qanats, approximately 750,000 kilometers. That's 1.5 times the distance from Earth to the Moon. All dug by hand, over 3,000 years. Here's what's incredible. Many are still working. After 3 millennia, water still flows. Cities still drink from 2,000-year-old aqueducts. The UNESCO World Heritage Site Qanat of Nushabad has been continuously operating for over 2,700 years. Same tunnels, same water, same engineering. Building qanats was deadly.
Workers descended into shafts hundreds of meters deep, dug by candlelight. Cave-ins killed thousands. Oxygen deprivation, flooding. Ancient texts record Mukanis as heroes, respected, well-paid, but many died young. The Qanat system spread from Persia across the ancient world, Middle East, Syria, Iraq, Jordan, North Africa, Egypt, Libya, Morocco, Asia, Afghanistan, Pakistan, Western China, Europe, Spain, brought by Muslims called qanats or acequias. Every civilization that conquered Persia learned the Qanat system and took it home. Today, as climate change intensifies, engineers are studying qanats. How did ancient systems work for 3,000 years with zero energy input? No pumps, no electricity, just gravity and brilliant engineering. Some modern water projects are incorporating Qanat principles, low-tech, sustainable, proven over millennia.
The underground world of Iran is still being discovered. Construction projects in modern cities keep breaking through into ancient structures, and archaeologists have barely scratched the surface. Isfahan, the Jama Mosque, one of the oldest in Iran. Beneath it, a complete second mosque, underground, same size, same architectural complexity, built during periods when Islam was persecuted, hidden worship spaces. Tabriz, historic bazaar, UNESCO World Heritage Site. The visible market is impressive, but beneath it, a second bazaar, lower levels where merchants stored goods, lived during winter, escaped summer heat. The underground bazaar connects to qanats, water supply integrated into the commercial district, temperature regulation, fire protection. Southern Iran, Kish Island, 2004 discovery during construction, a massive underground structure, over 10,000 square meters, multiple levels. The unique feature, it's not carved from rock, it's built from coral stone. The entire city is made of blocks cut from fossilized coral, lighter than rock, easier to carve, naturally porous, built-in ventilation. Archaeologists debate its age, 500 years, 1,000 years? Some features suggest it could be even older. Northern Iran, near the Caspian Sea, 3-level underground city, discovered 2001, still being excavated. What makes Saman unique? It's in a green region, plenty of surface water. So why build underground? The answer is earthquakes. Northern Iran sits on major fault lines. The underground city provided earthquake-resistant shelter. During tremors, people descended. The flexible tunnel design absorbs seismic energy, safer than surface buildings. Modern technology is revealing even more. Ground-penetrating radar surveys show anomalies beneath dozens of Iranian cities, voids, tunnels, chambers. Many have never been excavated. Permission issues, funding, or they're beneath modern buildings, impossible to access without demolition. Archaeologists estimate they've explored perhaps 5 to 10% of Iran's underground structures.
2019, Tehran Metro expansion. Tunneling hits an ancient chamber. Construction stops. Archaeologists descend. A Sasanian-era structure, 1,500 years old, perfectly preserved because it was sealed. 2021, highway construction near Kashan. Workers break into a qanat, not on any maps, not in any records, still flowing with water, probably 1,000+ years old, forgotten but functioning. These discoveries happen regularly. Almost every major construction project in central Iran encounters something underground. Many underground structures are collapsing. Groundwater depletion causes settling. Modern pumping lowers water tables. Ancient tunnels that were stable for centuries are now cracking. Urbanization is another threat. Heavy buildings above, sewage systems leaking into qanats, vibrations from traffic.
The Iranian Cultural Heritage Organization is racing to document structures before they're lost. Laser scanning, 3D modeling, digital preservation. But the scale is overwhelming. Thousands of kilometers of tunnels, hundreds of underground cities, limited funding, limited time. How did they do it? Ancient Persians with bronze tools created engineering that still impresses modern civil engineers. Several mysteries remain. Qanats maintain a 1 in 1,000 gradient, over 50+ kilometers, underground. They couldn't see the endpoint, no GPS, no laser levels, no theodolites. Theory, they used astronomy, star positions to calculate angles, water levels to check gradients, string and plumb bobs for vertical alignment. But achieving this accuracy over dozens of kilometers with the tunnel underground where you can't see surface landmarks, the mathematics required were incredibly sophisticated. Some engineers believe there are techniques we've lost, knowledge that disappeared when the oral tradition of Muqanis died out. Nushabad's ventilation still works after 1,500 years. Fresh air 18 meters down, no mechanical systems, just carved stone shafts.
Modern engineers analyzing the system found incredibly precise shaft placement, angles calculated to maximize airflow, cross tunnels creating convection currents. The ancient builders understood fluid dynamics at a level that wasn't formalized in Western science until the 18th century. They didn't have the equations, but they understood the principles. How? Trial and error over generations, or mathematical knowledge we don't know they possessed? These tunnels have survived 1,500 to 3,000 years of time. Hundreds of earthquakes, groundwater fluctuations, the weight of buildings constructed above. Modern tunnel engineers study them, the arch designs, the support pillar placement, the rock-cutting techniques that maximize stability while minimizing effort. Some Qanat tunnels are only 60 centimeters wide but 2 meters tall, oval cross-sections. This shape is perfectly engineered for stability. The ancient builders knew that circular tunnels waste effort and material. Oval is optimal. They didn't have finite element analysis, they didn't have computer modeling, but their tunnels outlast modern infrastructure. Building a 50-kilometer Qanat required hundreds of workers, working simultaneously on different sections, digging from both ends to meet in the middle. Margin of error when two tunnel teams meet after digging kilometers from opposite directions? Often less than a meter, sometimes centimeters. How did they coordinate? How did they communicate progress? How did they ensure the tunnels would align? Some researchers suggest acoustic signaling, workers tapping on rock walls, sound traveling through stone. This has been tested, it works, but the level of precision required is still astounding. The last traditional Muqanis died in the late 20th century. With them went oral knowledge passed down for 3,000 years. Some techniques are lost. Modern attempts to build Qanat-style systems using traditional methods have failed. The gradients are wrong. The ventilation doesn't work. Something is missing. We have the structures, we can measure them, study them, but we can't fully replicate them. Above ground, Iran is a nation of 88 million people, modern cities, highways, technology. But beneath the surface, an ancient world still exists. Some Qanats still supply water to villages. Farmers irrigate fields using systems built before the Roman Empire. The water tastes the same as it did 3,000 years ago. Some underground cities are tourist attractions now. Nushabad offers tours. You can descend into the darkness where ancient families hid from invaders, walk tunnels carved by hand, feel the cool air flowing through 1,500-year-old ventilation shafts. Other structures remain hidden, sealed chambers beneath modern homes, tunnels running under office buildings, a parallel world forgotten by those walking above. As global temperatures rise and water becomes scarce, engineers are looking to ancient solutions. Qanats offer lessons: zero-energy water transport, no evaporation loss, sustainable for millennia, low maintenance. Countries in similar climates, Middle East, North Africa, Central Asia, are reviving Qanat technology, ancient engineering solving modern problems. We still don't know the full extent of Iran's underground world. How many cities? How many kilometers of tunnels? What structures remain undiscovered? Every new construction project is a potential archaeological discovery. Every sewage repair could break through into a forgotten chamber. The underground world of Iran is not just history, it's present, active, waiting. The ancient Persians faced an impossible problem: build civilization in a desert. Their solution? Go underground. Create a hidden world. Master engineering that still impresses us today. They didn't conquer nature, they adapted to it, worked with geology, with gravity, with the natural flow of water and air. 18 meters down, 3 stories deep, carved entirely by hand, water flowing for 3,000 years, cities hidden beneath cities, an underground empire the size of continents, the impossible world under the ground of Iran. And we've only explored 5% of it. Somewhere beneath the Iranian desert, there's a tunnel, hand-carved, ancient, forgotten, water still flowing through it, air still circulating, waiting for someone to rediscover it. The underground world is patient.